Yes, good morning, students. Am I audible in both classes? Am I audible in both classes?
Yes, ma'am, sir.
Kindly type in chat. Wait a minute. Okay, what about now? Yes, I am audible in both classes. Fine. Okay. So in day 14, today is day 14. So in day 14, we are going to continue with the LCD. In the previous session, we have discussed how to interface LCD with a microcontroller and how to program it. Fine. So in this session, we are going to continue it. So in this session, we are going to create some pattern, and we are going to write it in the CGRAM. So based on that value, what we are writing in the CGRAM, the character is going to be appear on the screen when we are displaying the particular character we generated. Fine. So this session, our interest is to generate a character pattern. Okay, and we are going to display it on the LCD. So that is the scope of today's thing. Fine. So I want to recollect again. So this is about the hardware connection. Already we have discussed the entire port 2 we are connecting to the data bus of the LCD driver D0 to D7 or DB0 to DB7. Okay, fine. Then we are connecting the control signal RS, RW and enable to the port pin P3.0, 3.1 and 3.2 respectively. Fine. Then regarding the power supply, VSS must be connected to ground, VDD must be connected to plus 5 volt, VEE must be connected to a variable voltage through a potentiometer. Fine. I hope this and all clear to everyone. Yes. Is these things are clear to everyone? Yes. Fine. Fine. Okay. Next. So these are the commands I have told you. These are the commands I have told you. Here in this particular session, we are going to focus on this thing. Yes, set CGRAM address, and we are going to write some pattern on it. We are going to write some pattern on the CGRAM. Fine, to display a particular character. So after you have written the character in the CGRAM, you can access it. Generally what we will do, if A means the character A appears on the screen, if B means the character B appears on the LCD screen. So what about the value we are writing is the ASCII value of A, ASCII value of B. Fine. Similarly, in the driver LCD driver HD77480U, okay, user defined characters are mapped from the memory 0 to 7. Yes, yes, it is mapped to the ASCII value 0 to 7. Fine. If I write the ASCII value as 0, it will display the first character what we have generated, and it is available in the CGRAM. Yes, if I put 1, second character. If I put 2, third character. Similarly, if I put 7, it will show the 8th character. Fine. So whatever the character we are generating in the CGRAM and storing in CGRAM, it can be displayed on the LCD using the ASCII value from 0 to 7. Is this thing is clear to everyone? If I want to display the number 9, so the ASCII value is 39. Fine. So when I'm writing a string value into the data bus and making the data enable, so at that point of time, what is happening? The ASCII value for the particular value is going. Fine. In double quote, whatever we are writing, it is going to be the string. Fine. Each character in the string, it is going to have its own ASCII value. So that only we are writing in the data line and making the controls enable. Fine. Okay, here coming to the CGRAM, that character what we generated. So if I want to display it on the LCD, I have to use the ASCII value starting from 0 to 7. Is the thing is clear to everyone? Is the thing is clear to everyone? Or else I have to repeat. See, in yesterday we have written one program, correct? So in that program we have passed one string value to the function LCD underscore display, correct? At that time, what we have did inside the function, in the data line, in the 8-bit data line, we have kept the ASCII value for the first character. Fine. Mess of I, like that we have put. Initially I equal to 0. So mess of 0 means the very first character available in the array whose ASCII value is going to be written. Fine. Similarly, user-defined characters can be accessed with the ASCII value start from 0 to 7. 0x002 0x07. Fine. I hope it is clear to everyone. Now what I am going to do is I am going to provide you these things. Kindly take screenshot of this. In the previous class itself I have displayed you. Kindly take it. At any point of time we should know this. How to form the command to do a particular operation. Yes, we have to know it. See, regarding command, these two lines are control lines. Don't consider this. Fine. So the command word is 8-bit only. D0 to D7. This 8-bit only. Fine. Okay. So write an embedded C program to generate and store the following pattern in CGRAM from address 000000. How many bit address I am using? It is in binary pattern. So how many bit address I am using? What about the size of the address bit? In the previous class itself I have told you. Is it 7 or 6? Kindly count and tell me. Yes, 6-bit address. Very good. 6-bit address so that we can address how many memory location? So that we can address how many memory location? With 6-bit, yeah, 64 memory location we can address. Fine, very good. Fine. Okay, this 64 bytes of memory location, that CG RAM, is split into 8 division. Yes, for generating a pattern, okay, for generating a character, you require 8-byte for a single character. For generating a single character, you need 8-byte memory. Yes, so that you can have 8 bytes memory for a single character. So like that you can create 8 characters. Simply we can say 64 cross 8 bit memory location is available in CGRAM. So that memory, what we are going to do is we are going to divide into 8 sections. The first section for first character, first user defined character. The second section for second user defined character. Similarly, we can create up to 8. Yes, totally we can create 8 characters. Okay. So this pattern we have to generate. This pattern first we will generate. Later point of time, you people tell me some character. I will generate it. Yes. Yes. Shall we proceed? This pattern, this smiley, what I am going to do is I am going to display on the LCD. Yes, fine. So where we can store this particular pattern? The first 8 memory location 0 to 7 in the CGRAM, that is going to be user defined character 1, whose ASCII value is going to be 00. If you write the data as 00 in the data line, this particular smiley will appear on the LCD screen. Is it clear? Okay. For setting the CGRAM address, this command has to be used. Yes, for setting the CGRAM address, this command has to be used. Which memory location I am going to start? Yes, from which memory location I am going to start? Yes, 0000. Yes, very good. Fine. Okay. Shall we start writing the program? Shall we start writing the program? So what about the value I have to write? Substitute it and tell me. CGRAM address is 000000. You substitute it and tell me to which address I have to start writing the 8 bytes. Yes. Is it 80 Anthony Surya? Yes, very good, Logus Nega. You just substitute the CGRAM address here. 6-bit address only we are having 0000000. So you will be having 40H. Is it clear to everyone? Fine. Coming to the next point, DRAM size. Already I told 64 cross 8 bit. So to address 64 byte, we have a 6-bit address. This is the reason why we are having 6-bit address here. Fine. Then one more thing we have to note down. For this particular pattern, we need to find the data. ஒவ்வொரு row எடுத்துட்டு நான் என்ன பண்ண போறேன், it has to be converted into hexadecimal value. Fine. So consider this position as a LSB, last column as LSB. So lower 5 bits only we can able to program. The upper 5 bits are don't care. The upper 5 bits, sorry, upper 3 bits are don't care. Only lower 5 bits will be considered because the display size is 5 cross 8. Correct? Yes. Okay. Now you people type in chat. What about the data I have to write in the first memory location? See, this is the order of the memory I have to write. What about the first data I have to write in the CGRAM? I can see your chat. Wait a minute. Yes. Kindly type in chat. First character. I mean, you consider this is the 0th location in the CGRAM. Next one is 1, 2, 3, 4, 5, 6, 7. Yes. So this 8 pattern I have to write in the CGRAM. Yes, kindly help me out, people. Yes, kindly help me out. See, consider this particular bit is going to be 0. Yes, you fill 3 zeros before this, so and convert it into hexadecimal number and tell me. Already 5 zeros are there. Before 3 0 you put, what about the first data I have to write? What about the first data? Yes, very good. What about the second data? You fill 3 zeros before this number. Yes, you fill 3 zeros before this number to make it as 8 bit. The memory location is 8 bit, but only lower 5 bits are considered or valid thing. The upper 3 bits become don't care because we are having only 5 columns in all the character window. Yes, very good. 0A. Yes, the next 3 location I have to fill 0A. Correct? What about the next location? Obviously, already you told 0, 0. Yes. What about this location? This location. What about the data I have to write? In this location. Yes, very good. 11H. Very good. Do you people understand how we are forming? You put 3 zeros before this data. Okay, 5 bit, and you convert it into hexadecimal value. Yes, 1 1. What about this thing? This thing. This line. Yes, 0E. The last line is going to be 0x00. Okay. Can any one of you type all the 8 bytes in a row? So that I can copy and paste it in the program. Yes. So 0x00. Next data is 0x0a. 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 0x00. 0x11. 0x0e. 0x00. 8 bytes we need to define a single character. User defined character. Fine. So like this you can create up to 8 user defined characters. So this is one character we are generating. Similarly, we can create another 7 characters. So totally we can create up to 8 characters. Yes, is this thing is clear to everyone? Shall we start writing the program? Yes, wait a minute. I'll open the software. Please wait. Not opening. Wait a minute. Wait for some time. I'll reinstall the software. See, if the software is not properly working, you just reinstall it. It might solve your issue. Okay. Many of you people told you will be having some problem with using this particular software. Okay. So I will help you out. Those people, if you are having a problem with your software, you kindly contact me. I will provide you the solution. Just wait a minute. Yes, it got open, I think so. Okay, fine. Okay, I'm going to close this particular program. Wait a minute. Project, save and close. So already yesterday we have opened one project, correct? So that I am going to open again. So LCD demo. Here we have. So that project I am opening. Yes. Now I am going to open the source file, what we have done, or else we can do new one. Okay, that's fine. New one. I'm going to create a new one. I'm going to save it as LCD CG RAM. I'm giving some name like this. Yes. Yes, in the previous class itself, we have created one header file. I'm going to make use of that header file. Fine. Okay. Thank you, Shivakumar, for your response. I will make use of this particular character. Fine. The first line, what we have to do? Obviously, the very first line, what we have to do? Yes. Yes, we have to include the header file. Very good. So, hash include AT89S52.h. Very good. So what about the next lines I have to do? Before using the LCD header file, I have to define what is LCD. Okay, what is RS pin, what is RW pin, and what is EN pin. Yes, so I have to define it as define. In the header file, you have used the port as a LCD, the data port as a LCD. Yes, LCD P2. Very good, very good. Okay, then next what we have to do? As define RS P3_0. Very good. Fine. Next, as define RW P3_1. Next, as define EN_2. Fine. Now we have to include the header file. Include lcd.h. Do you know how to use our header file? In the header file, I didn't define what are all the meaning for LCD, RS, RW, and EN. Correct? I simply use the keyword. So in the main program, you have to define it. After that only you can include the header file. Otherwise, what will happen? It will generate you error. Okay. Fine. Now we can write the main program. So before that, what I'm going to do is double underscore code const I'm going to give the name as uh, pattern one or something we can say. What naming we can give for that particular pattern? I have to create an array here, character array. So what naming we can give? Yes, smiley. Very good. Yes, smiley. Okay. So here I am going to give the values 0x00, 0x0a, 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 0x00, 0x11, 0x0e, 0x00. Yes, do you people understand what about this line of coding? I am just creating that pattern, okay, and assigning to the array named as smiley. So it is going to be a character array. Fine. See, if you are displaying a number, you can put it in double string. But if I want to declare some variable, okay, or values in an array, so I have to go like this. Fine. Now we can write the main program. Void main. Yes, void main. So in the main program, what we have to do initially, en must be initially made as 0. Then we have to check whether the LCD is busy or not. Yes, so LCD busy or not, it will check. After that, it will come. Fine. Now what we have to do? Or else you can use directly LCD init, because in that function itself we have included the LCD busy function. Yes, so LCD will get initialized. Please kindly understand one thing. In the header file, okay, we had written one function LCD underscore init. If you call that particular function, what are the things will happen? என்னென்னலாம் நடக்கும்பா? Yes, what are the things will happen? Function set, the first command we have given, 8-bit interface, 2-line display, 5 cross 8 font, correct? That will be initialized. Next, the LCD, whatever data we have written previously, it will get clear. That's the next step. Third step, what we did, display turned on. Yes, only display we have turned on. Yes, next step, entry mode set, that we have done. What about the fifth command we have given? Set DDRAM address. That is the last command I have given, correct? Suppose if you are start writing it to the data line and making the things enable, fine. So it will be printed on the LCD screen. 0, 0A, this character will try to print on the LCD screen. Fine. So it won't work. What I have to do? I have to give one command word. What command word I have to give? To write in the CGRAM, what command I have to give? Yes. What must be the command word I have to give? Students, kindly help me out. See, I have initialized the LCD. According to the initialization function, it will set DRAM address. So whatever you are writing, it will start displaying, try to display. But what we need to write in CGRAM. Yes, to write in CGRAM, we have to set the CGRAM address. What about the command we have discussed earlier? I'll show you. Yes, very good, very good, very good. 40 is the command we have to use. Very good. Thank you. So what I have to do for this? To issue command, I have created one function. Do you people remember? LCD underscore. To issue command, what function I have declared? the previous session in the header file. Yes, very good. LCD underscore CMD in bracket. I have to give the value as 40. That's it. So now whatever you are trying to write on the data line, it will be stored into CG RAM only. Fine. So here what I am going to do is while initially I have to create one variable to point the first character. So I am going to create a character C equal to 0 initially. While or else you can go for loop, that's fine. You are going to write only 8 characters right now. When you are displaying some string, you don't know how many characters. You have to count down and you have to write a for loop. For that purpose only I am going with while loop. If you know how many characters you are going to write, you can put it in a for loop also. That's fine. So what we can do, simply we can create one variable C. Here I can go for loop better. For C equal to 0, C less than 8. That means I am going to write 8 byte of data 0 to 7. Yes, C plus plus. So inside this for loop, what we have to do? LCD underscore data. I am going to write the data, but it is going to be written on where? DDRAM or CGRAM? Where it will get written? DDRAM or CGRAM? If I write the data, where now the data will get written on? CGRAM la poi store aguma, DDRAM la poi store aguma. Yes, kindly help me out. Yes, CGRAM only. Okay, I think Anthony Surya, you have frequently disconnected from the internet. Probably you may not able to follow what I am saying. Okay, fine. Here one command we have given at last. What is the meaning for this? Set CGRAM address. So whatever the data you are going to write now, it will get stored in the CGRAM only. Okay, is it clear now, Anthony Surya? The last command, what you have given? Set CGRAM. Okay, fine, fine. So smiley of C. So initially C equal to 0, correct, in this for loop. So first character will be written. Is it clear to everyone? That's all. We have stored the pattern. Now we can able to display. Fine. While of 1. So I am going to display the character now. So what I have to do now? After generating the character pattern, I want to display it. Yes. For this, what we have to do? We have to write in DDRAM. See, CGRAM I am using to generate character pattern. Now what I have to do? I have to write in DDRAM. The very first memory location I have to point, or second location we can point. So what I have told in this particular program to do? And display it on the whole second line of 16x2 LCD display. Yes. If I say second line first character, what will be the address? Do you people understand what I am speaking? I have created the character pattern. Now I want to display it. See, using this line, I have created the pattern. Yes, very good, Anthony Surya. We have to give another command, LCD underscore CMD of 0xC0. So why I am writing this particular line? I am going to, yes, I'm going to point to the second line first character. Now we can write it. Fine. How many characters we can display on the second line? Any idea? How many characters totally we can display on the second line? Totally how many characters will be there? Second line. It is 16x2. Yes. How many characters we can able to display on the second line? Whether 8 or 16. Yes, 16 characters. So now what I'm going to do is I'm going to create another for loop for c equal to 0, c less than 16, c plus plus. Okay. And here what I'm going to do, I'm going to write the data. LCD underscore data, LCD underscore data. Yes, here what value I have to put, which I want to display in the display, LCD display. Smiley. What about the ASCII value for the smiley? We have created first 8 memory location. It is stored in the first 8 memory location. What about that value assigned for that ASCII? I mean, what about the ASCII value we have assigned for the smiley? 0x00. Second character means 1. Yes, third character means 2. Totally we can have 8 characters. The ASCII value for the generated characters are from 0 to 7. First memory location la na idu pannadanaala adoda address vandu adoda ASCII value vandu 0. It is predefined by the manufacturer. Okay. So idhula edavadhu doubt irundhuchana kekkalam. Yes, in this main program if you have any doubt you can ask. As I am using header line, the program is become very simple. I am declaring one variable for counting purpose. Yes, initially I am disabling the enable line. Next, I am initializing the LCD. Then I am creating the character pattern and store it in the CGRAM from 0 to 7. That's why I have given the starting address as 40. Fine. Now I am writing the data what I have created. The ASCII value to display that particular generated character is 0. So 0x00. Yes. Shall we simulate this particular program? Yes. Shall we simulate the particular program? Yes, fine. So now what I'm going to do is I'm going to take virtual hardware. So in the previous class itself, we have created the hardware. So I am going to make use of it. Fine. I'm going to keep it here. I'm going to turn it on. Okay. Simulator. So we have to run the program. File, save, simulate, debug this file only. Yes. Yes. Now we can run the program. Wait a minute. Yes, we can see the timing. I don't need to wait. Yes, can you see the CGRAM here? The pattern got created and it is start displaying. Second line மட்டும் எல்லா இடத்துலயும் நம்ம display பண்ணிருக்கோம். Yeah, we have created our own character and displayed in the LCD. For example, some of the symbols or some of the things you may not have in the CGRAM. Already predefined memory sonolingla. If it is not available, we can create. But the limitation is we can create only 8 characters. Can create only 8 characters. Yes, is the thing is clear to everyone? Is the thing is clear to everyone? Yes, fine. Okay, now you people suggest me a character I want to display. Yes, now you people suggest me a character that you want to display, generate and display. You can put in binary pattern. Yes, you can put in binary pattern in the chat. So you should type in 8 line. Okay, 8 lines must be there. Each line you should have 5 bits, or you can put 3 zeros before the data and write 8 bits. Fine. Can you people type in chat so that we will check it whether it is working or not with some other character. So we can create our own character. That's fine. Yes, anybody? You just form the pattern like this. I'll show you. Yes, like this you will form your pattern and put it in the chat. We can display it. Yes, I'm waiting for your response. You have to keep like this. Whichever pattern I want to make dark, I have to put 1. Other position I have to make it 0. Yes. So that you people understand. You people will feel, yes, it is working fine. See, this pattern I have created, kindly you people suggest me 8 data so that you can generate your own character. Yes, thank you, Anthony Surya. Yes, I think Anthony Surya put the value. Fine. Okay, we are going to generate this particular pattern. Okay, so what about the data 666? Okay, then 1F 1F 666. Wait a minute, Anthony Surya. I will type it. So as per the data given by Anthony Surya, the first character, I mean the first line to generate this particular character is 06. Next one is going to be 06. Next one is going to be 06. The next two characters are going to be 1F, 1F, then again 06, 1, 2, 3, 4, 5, 6, 7, 8, 6, 6, 6. Okay, here I missed out. Wait a minute. 1F, 0x, 06. That's it. Okay, now we can compile the program and run it once. Yes, now we will display it. Wait a minute. Yes, it is running now. So we manually reset the busy flag to see the output. Yes, is it okay, Anthony Surya? Yes, that's it. Like this, you can create any character you want to generate. Fine. So that's all about the program to generate the own character and displaying it. Fine. Okay. See, you people, it's under the control of you people. Fine. You have to go through the command words. We are having variety of command words. Wait a minute. Yes, you people are having variety of command words. So you can do different things. Fine. If I want to generate the next character, if I want to generate the next character, where you have to write the program, where you have to write. So this is smiley. Fine. Wait a minute. I will do one thing. I will do one thing. Wait a minute. Yes. So now what I am going to do is, so this is going to be character pattern told by Anthony Surya. Fine. What I can do is, I can change this particular value. Instead of 40, I am going to change it as 48. Yes, I'm going to change it as 48. That means what? Yes, that means what? Sorry, students, I think my laptop will get turned off. There is no power here. Wait a minute. If I am disconnected from the meet, I will join in the other laptop. Okay. So now if you are using 00, here it is meaningless. Yes. Here if I put 00, it is going to be meaningless. Why? Where I have started creating the character? From the 8th memory location. Correct. 48 means from the 8th memory location. That means what? The second character, what I am generating. So here you have to put 1. That 8 byte, it is mapped to one ASCII value. So whatever the ASCII number assigned for that particular group of 8 byte, you have to put it here. Fine. Okay. Now I will do two things. So I'm going to repeat two patterns. Wait a minute. I'm going to have 8 as a count. And LCD underscore data equal to 1. LCD underscore data equal to 0x00. Wait a minute. We will see. What about the character we can able to see in the display? Can you see it? Now it is getting generated in the second position. Correct?
Ram sir? Ram sir?
Yes, now I have joined. I think so. My voice is audible. Yes. Okay. So now what we can do is we can go with some serial UR programming. Fine. At the end of today's session, possibly the last half an hour, that means by 11:30, we can start. We can start with the presentation. Okay. I have told few students from ECEA class. Fine. So already 2 students got excuse and 1 student now telling the software is not working fine. Okay. So the remaining 3, I will say the names. Wait a minute. Yes, Indra Priyadashini, are you ready to present your task by today? Yes. Indra Priyadashini, can you hear me? Kindly respond.
Ram
Roll
sir, அவங்க
number
இல்ல.
121. Okay. Roll number 112. Dixon, are you ready to present your task?
சார் நான் கம்ப்ளீட் பண்ணிட்டேன் சார்.
Dixon. ஓகே.
ஆனா சாஃப்ட்வேர் என்கிட்ட லேப்டாப்ல சப்போர்ட் ஆகல சார். அந்த சாஃப்ட்வேர் இன்ஸ்டால் பண்ண முடியல. ஆனா டாஸ்க் கம்ப்ளீட் பண்ணிட்டேன் சார்.
Okay, fine. See, if you peoples are having issue, kindly inform me prior. Okay.
Okay, sir.
Yes, from the day one, I am thinking you peoples are working out. Okay. So இந்த மாதிரி issue இருந்துச்சுன்னா எனக்கு சொல்லுங்க, நான் ஸ்டார்டிங்கே சொல்லிட்டேன் இல்லைங்களா? Many of you are saying the same reason. Fine. What about Sugandh? Thank you, Dixon. What about Sugandh?
Yes, sir, I can present, sir.
Okay. Last 10 minutes I will give you. 10 to 15 minutes I will give you. Okay. Now I will continue with the serial UR programming. Yes. Yes. Tell me, Sugandh.
Sir, just the presentation itself, okay, sir. And
yes, you have to
of the
present and yes, you have to explain what are the lines you have written.
Okay, sir.
Okay, what
Okay,
is the
sir.
meaning of that? That's enough. Okay.
Okay, sir.
Fine.
Thank you, sir.
Thank you, Sugandh. Regarding module 2, I will assign some tasks. Okay, so those tasks, it is going to be integrating more components. See, in the case of module 1, we have used only switch, LED, switch 7 segment like that. Okay, so here I will be assigning keypad, LCD, fine, LED. So these combinations will come. Fine. So you have to get a 4-digit pattern. You have to get a 4-digit pattern from a keyboard. Okay. So you have to compare with the predefined password and you have to check it whether it is matching or not. If it matches, you have to make the LED to turn on. Like that, I will assign you some task. Okay. Fine. So later we will go with it. So now I am going to open the software. Wait a minute. See, I have arranged everything to show the output for you people in today's session, but unfortunately there is no power. So without power, my another laptop won't work for a long period. So we'll go with the serial UR programming. Okay, now we are going to go with the serial UR programming. So I'm going to delete everything. So already we have written the serial UR program. Okay, without interrupt. Now what we are going to do is we are going to do with interrupt. What it means? With interrupt means whenever interrupt occur, it will enter into the service program and it will start executing the service program. Once service program is over, it will come to the main program. That means you can relieve your controller to do another operation. In the case of the first one, what we did is we have used the serial UART available in 8089S52, but we have checked whether the data got transmitted or not. Yes, that particular line of coding, your controller is waiting till the data byte getting transmitted. Yes. Okay. Now in this class, what we are going to do is we are going to receive a byte of data from another device. We have to assume there is some device we are going to attach to the serial port of 8089S52, which is going to provide you an information. Fine. Once you have received a byte of data, you have to check whether the data is 0 or 1 or 2 or 3. What about the number? Fine, you can assign it. Fine. You have to compare that particular number if that matches with the predefined value, what you have told. Say, for example, if I receive the character or the number as 0, fine, my LED should get turned off. If I receive a value as 1, my LED should get turned on. Like that we can write. Based upon the value given by the serial device, we are going to control the device connected at the port. Fine. So that portion we are going to do now. So for this, the very first line, usually what we will write? Kindly help me out. So now we are interested in doing the serial UART program with the interrupt. That is the concept here. Okay. Fine. What about the first line we have to write? Wait a minute. I will open the Google Classroom, Meet link so that I can see your chat. Fine. Now I will present you. Wait a minute. I'm not presenting anything. Now only I'm going to present. Wait a minute. Yes, I hope my screen is visible to the other end. Yes, is it visible now? Yes, okay, fine. Yes, okay, fine. Only few people are replying in classroom 2. Thank you for those 2 people. Fine. Okay. So now we can write the program. What about the very first line we have to do? What about the very first line we have to write? Usually. Yes, as usual, we have to include the header file. Fine. So hash include yes52.h. That's it. Okay. Now I'm going to use the serial UART. You can do 2 things. One is you can calculate the count. Okay, that should be loaded in timer 1 so that we'll be getting a proper baud rate. That is one thing. Or else you can do like this. Has define FOSC 11059200. Fine. As defined TCLK, T clock, timer clock, it is going to be FOSC divided by 12. I am handling in terms of frequency. Okay, fine. Next, has defined S clock, serial clock, so which is equal to TCLK divided by 32. If S mod is equal to 0 means you have to put 32. If S mod equal to 1, if you are going to do this, this value must be T clock by 16. Now to find the count value. Yes, has defined count. So what about the count value? 256 minus CLK divided by baud rate. Yes, so I have to define the baud rate also before this. Has defined BAUD. So 9600 I am going to put. Fine, that's it. Now we can start writing the program. You peoples are going to help me. That's it. So void main in this function. In this function, what about the very first line I have to do? I need to program the serial UART of 8089S52. What about the very first line I have to write? Yes. Wait a minute. Yes, okay. I'm in the meet only. Fine. Okay. Kindly help me out. What about the very first line we have to write regarding the serial UART programming? What are the steps we have to follow? Yes. Students, kindly help me out. I'm waiting for your response. Yes, we have to configure the mode. Very good. We have to configure the mode. We have to configure the mode of operation. So S1 is equal to what value we have put? 0x50. Yes, correct or not? Yes, very good. Okay. Next, what we have to do? We have to configure the timer for generating that particular baud rate. What about the first thing? I need to program the timer 1 now. Yes, I need to program the timer 1 now. What we have to do now? Yes. Yes, TR1 is equal to 0. Very good. TR1 is equal to 0. We have to stop the timer 1. Very good. Next. Timer 1 must be preferred to configure in mode 2. Right? So that's why I have used this particular formula. Actually 255 minus this value, right, plus 1. That I am rating it as 256 minus that S clock by bar. Yes. T mod is equal to T mod and of 0x 0f. That should be odd with 0x20. Yes, very good. See, always have the habit of writing program like this. You should always consider the other timer also. Fine. Now, P mod we have programmed. Now we have to add one variable. So that is going to be a character variable B. Fine. Here what we have to do? PH1 is equal to P. Similarly, PL1 is equal to P. Next step, what we have to do? Next step, what we have to do? What about the next step? Count value I have put down. Next step, what we have to do? Yes, students, kindly help me out. Timer stop பண்ணியாச்சு. We have to run timer. TR1 is equal to 1. Very good, super. So now we have to run the timer 1. TR1 is equal to 1. Okay, fine. So now I have to do one thing. I'm going to use interrupt concept here. I want to enable the serial interrupt. So what are the things I have to do? To consider the, yeah, very good, Anthony Surya. We have to enable the interrupt. What are the things we have to do? I want to enable only serial interrupt. Yes, very good. EA must be 1. So this will enable the option of masking and unmasking. Yes. So what about the individual bits? Which bit I have to set so that serial interrupt will get enabled? Yes, very good. So first I have to do ES equal to 1. Next I have to do ES equal to 0. Sorry, EA equal to 1. So these are the steps you have to follow in the main program. Now, while of 1. I am going to do nothing now. Yes, in between this while loop, in between this particular while loop, you can write any task. Any task you can do. That means what? Whenever, see what program I wish to write is whenever a byte received by the serial port, okay, it should compare the value and do some operation. If you are able to do this, you can do home automation. You can do home automation. Yes? Yes, is it clear to everyone? Yes. So now what I have to do? I have to write a interrupt service routine. What is the syntax we have to use for the interrupt service routine? So what about the syntax we have to use? Void. You suggest some naming. I'm going to use it as my serial. You can give any naming. My serial. Okay, serial int. Anthony Surya suggested serial int. Okay, serial int of void. Okay, here double underscore you have to put interrupt. About the numbering we have to give, that is very, very important. 0 means external interrupt 0. 1 means timer 0 overflow interrupt. 2 means external interrupt 1. Correct? 3 means timer 1 overflow interrupt. Yes, 4 we have to give. Very good. So you people have to understand why 4. Already I have told you how the vector address is calculated. How the vector address will get calculated? The number multiplied by 8 plus 3. Correct? So we have to do like this. Yes, very good, Anthony Surya. N into 8 plus 3. Very good. So I am putting 4. If you calculate 4 into 8 plus 3 in hexadecimal, you will get 0023H, which is nothing but the vector address of serial. I have told you already regarding the other interrupts. When it enters into the ISR routine, automatically its interrupt flag will get clear. So we no need to clear it. Okay. In the case of serial interrupt, there are two sources. One is the interrupt is due to what? What are the two sources we are having here? Yes. Kindly help me out. Students, kindly help me. See, we are having two reasons to come into this service routine. What are the two reasons? When serial interrupt occur? When serial interrupt occurs, see, when serial interrupt will get generated, yes, at the end of transmission or if you received a byte of data. So we are having two reasons. First, we have to check whether it comes into the service routine due to reception or transmission. How you can check it? How you can check it? If it is due to transmission, yes, we have to check TI. Otherwise, it should be RI. Correct? So first, we have to check RI. If it is due to reception interrupt, if RI equal to 1 means after entering this particular if statement, definitely you have to reset the bit. Otherwise, what is the meaning? Interrupt flag will not be reset. In the case of serial UR, we have to make it RI equal to 0. Nalla gavanachina theriyum. When we had written timer program, okay, when we had written timer program or external interrupt, we did such thing. TF1 number clear pannama, TF0 number clear pannama. No, never. Yes. One more thing you have to understand. As I am using timer 1 to generate baud rate here, timer 1 interrupt should not be enabled.
It should not be enabled, not at all enabled. Enable panna enna agum? Whenever timer get overflow, it will get into the ISR routine of timer program. Okay, see here timer is used only for generating the baud rate. That's why I am enabling only serial UART interrupt. Fine. Okay, if RA equal to 1, what about the next thing we have to do? What about the next thing we have to do? Yes, if RA equal to 0 means, sorry, RA equal to 1 means this value. Fine. After entering into this particular if loop, what we have to do? We have to assign one variable here. So what I am going to assign is char of rec received byte. Okay, char of, I mean it's a character variable. What I have to do? Now I have to read the register. Which register we have to read? If the data you receive, if you receive a data, where it will get stored in the microcontroller? Which register? To which register the data will get stored? That's my question. If you want to transmit some data, you have to write it in SBUF, correct? Similarly, if you are receiving a byte of data, where it will get stored? Kindly help me out, kindly respond. See, if it is due to reception interrupt, it enters into the if loop. Okay, I'm resetting the RI bit, fine. Then it has to read the data to the variable REC. For this, what I have to do? REC must be equal to what? Which register I have to read? Yes, very good, fine. SBUF. If I am writing like this, which SBUF will be addressed? Read only or write only? We are having two SBUF register physically. One is read only, the other one is write only. Which SBUF register will get accessed? Yes, read only. Very good. So now I have read the value. Next step, what you have to do? Next step, immediate step, what you have to do? Next immediate step, what you have to do? So what about the next step? You have to compare the value, correct? You have to compare the value. If it is 0, we have to turn off the LED. If it is 1, we have to turn on the LED, correct? Yes or no? Students, kindly respond. After I have read the value, what we have to do? If that value REC is equal to 0. Note down, I am expecting ASCII value of 0. In single quote, in single quote I am putting the value as 0, that means ASCII value of 0 I am checking. So what type of data we have to send from the receiver, transmitter? ASCII value 0. Fine. Okay, now what we have to do? For example, I am having two LEDs. Okay, or one LED. LED equal to 1. If I receive 0, I have to turn off, correct? So LED equal to 1. That means I have to define one LED. Wait a minute. As defined LED T2 underscore 0. This pin we can use. Yes, if I receive the value as 0, what I have to do? I have to write 1 to the logic. Else if. Yes, else if. Else if. What we have to do? else if REC, here I put single equal to, sorry for that, it should be double equal. Yes, else if REC equal to 1. 1 means what we have to do? 1 means what we have to do? LED equal to 0. Yes, correct? Yes, LED equal to 0. Fine. If both the things are not, else yes, if both the things are not, you can do nothing. You have to do nothing. Is the thing is clear? This line of coding for reception. So far I have written only for reception. Is the thing is clear to everyone? Yes, okay. Suppose if you need to have some feedback, that means an acknowledging. My end device, it is requesting the microcontroller through providing some serial data to turn on the LED. Yes, or to turn off the LED. If it gives some other input, means in the reception program, I should do nothing. Yes? Is it clear to everyone? See, I have to declare this particular variable globally. That point already I have told you. Whenever you are using some variable in the interrupt service routine, just declare it globally. Wait a minute. Yes. Okay. So initially there is no value. If we are receiving, it should be like that. Fine. Is the thing is clear to everyone? Yes. Else, if this is not happening due to the reception interrupt, what we have to do? Else if, simply else. There are only two conditions to enter into this service routine. One is RA equal to 0, the other one is TA equal to, RA equal to 1, the other one is TA equal to 1. So here, obviously, we no need to check. So simply TA we are resetting. Yes? Okay. I want to tell you one thing. Okay. Manually, we can also set or reset the TA and RA bit. Fine. Please carefully listen. After I have done this task, kindly listen. After I have done this particular task, yes, receiving the value, this line of coding, I am speaking about this particular line of coding. If receive interrupt bit should be clear. Yes, we have to read the value. If it is 0, we have to turn on the LED 1. I mean, we have to turn off the LED. Else if equal to 1 means turn on the LED, else nothing. So this is the thing we have written. Fine. So at the end, what you have to do is TI. Yes, TI equal to 1. I am manually triggering the transmit interrupt. Whenever TA gets set 1, after coming out of this loop, again it will come into the service routine only. Am I right or not? See, this kind of coding most of the people are not doing when performing home automation. Say for example, if I want to turn on my home appliance through Bluetooth or Wi-Fi or IoT, whatever it may be, fine. I am sending the value, by comparing that value, the controller is turning on or off the appliance. Am I right? Am I right or wrong? In the case of IoT or Bluetooth home automation or Wi-Fi based home automation, based upon the value the user is sending through the wireless medium, it is received and it is compared. Based on that, the appliance will be controlled. That's it. Fine. To get acknowledgement, yes, to get acknowledgement from the microcontroller, we should have some message written back to the user. Yes or no? Yes or no? Okay, இது மட்டும் first பண்ணலாம். Okay, இது மட்டும் first பண்ணலாம். Later I will go with the acknowledgement part. So now I am going to restrict with this. Wait a minute. I am going to restrict with this. Fortunately, I got the power again, power back. So I will present from my another laptop. Wait a minute. Wait a minute. I will copy this program and put it in chat, so that I can make use of it in the another laptop. So this is the line of coding I have put. Okay, wait a minute. I will join and share. Wait for some time. Just wait for some time. I will join soon. Sorry for the interruption, students. I want to show the output. That's why. Wait a minute. Okay, wait for some time. I will join in my another computer. Then I will come here. See, kindly go through this program. Kindly go through this program. Sir, am I audible?
Yes, Ram sir. Audible, Ram sir.
Yes, am I audible? Okay, wait. I will join from my another computer. Students, kindly wait. Kindly wait for some time. Join from another laptop. Wait a minute. See, the program what we have written is for programming the serial UART. Okay, such that If we receive data as 0, we have to turn off the LED. If we receive data as 1, we have to turn on the LED. For that purpose only, we are writing the program. Wait a minute. It's taking too much time. Okay, do you people have any doubt in this particular program? Yes, do you people have any doubt in this particular program? Kindly type in chat. I have posted in the chat also, right? That laptop is taking too much time. Wait a minute. I don't know why it is like that.
Ram sir.
Sir, am I audible now?
Audible, Ram sir.
Okay, okay. Wait a minute. Okay, now I will present my screen. A screen. Gun sir, can you put the code in chat again?
Ram sir, எந்த கோட் ராம் சார்?
நான் இப்போ chatல போட்டிருக்கேன் பாருங்க கோடிங் என்னுடைய அந்த லேப்டாப்லேயே போட்டிருக்கேன்.
எஸ் ராம் சார்.
Yes, சிவகுமாரும் போட்டிருக்காரு. ஓகே ஓகே ஃபைன். தேங்க்யூ சிவகுமார். Okay, fine. Okay, Moon sir. Mute பண்ணிக்கோ. Okay, students. I'll prepare the setup now. Wait for some time. So this program I have to compile. Okay, this program I have to compile. So file. I'm going to save it. Simulator. Debug this file. Yes. I think I made a mistake. Fix that. Yes, void main. I didn't. Void main bracket. Yes. Yes, now it's fine. Now it's fine. Okay, wait a minute. Yes. Sorry for the interruption, students. I'm making some arrangements so that it is taking time. Wait a minute. I have to go for new window. New window. In this window, I have to type. One 192.168. Yes. Okay. Thank you. Okay. What you are seeing in the right hand side is my mobile screen. Okay. Yes. What you peoples are seeing in the right hand side is my mobile screen. Don't get confused. Okay. Here is my program. Yes. Here is my program. So now what I am going to do is we are having a app which we have downloaded from the Play Store. Okay, this one Bluetooth Terminal HC05. So this app is available in the Google Play Store. Fine. Like this, we are going to create one app. Like this, we are going to create one application using MIT App Inventor from the upcoming sessions. Fine. So now I am going to make use of this particular app. Fine. So before that, I want to show you some components. Okay, I want to show you some components. Wait a minute. Yes, here what you are seeing is a Bluetooth module, HC05 Bluetooth module. Fine. Fortunately, I got this module with me. Fine. So that we can able to show you this. So this particular module, I am going to connect to the serial UART. Fine. I am going to connect to the serial UART of 8051 microcontroller. So in the reverse side, you can see the pin naming. Yes, we are having 6 pins: state, RxD, EXD, ground, ECC, and enable. Right? Yes. Can you people see this? Kindly anyone unmute and say so that I can understand, because I am filled with my screen. I cannot able to see your chat. Yes. Are you seeing the 6 pins? Is the screen is visible to everyone? Yes. Thank you. Thank you. Fine. So in this, what are the 6 pins purpose? Can you people identify? So for providing proper power supply, we need 2 pins. Correct? To provide power supply, we need 2 pins. So VCC and the ground, which are the input pin to the module. Am I right? Okay. Then you are seeing 2 pins, TXD, RxD. Correct? TXD and RxD. TXD means what? This pin. From this pin, whatever the data I am sending from the app, it is going to be transmitted through this pin. Fine. Through wireless medium, the data is transferring to the Bluetooth module. From the Bluetooth module, I am going to establish a wired connection between microcontroller and the HC05 module. Is it clear to everyone? So this TXD pin, where I have to connect in the microcontroller? Can anyone say? Yes. This TXD pin, where I have to connect to the microcontroller? Kindly unmute and say so that I can know. Yes, this TXD pin, where I have to connect? It is the transmission pin of this device. So where I have to connect so that I can receive in the microcontroller? See, this is the output pin where I should connect to the serial pin of 8051. TXD or RxD, where I have to connect? Students, I cannot able to see your chat. Kindly unmute and speak, or else wait, I will check the chat. We have to connect to RxD pin, Antony Surya. Yes. Wait a minute. See, here it is transmitting. So this pin has to be connected to RxD. That means generally when you are going for any UART device connection, RxD must be connected to TXD, TXD must be connected to RxD. Cross connection you have to do. Fine. Then we have 2 more pins, state and enable. Yes, state and enable. Fine. State means by reading this particular pin, you can understand whether a connection with the device is established or not. The Bluetooth module, இன்னொரு Bluetooth module ஓட இல்ல mobile phone ல உள்ள Bluetooth ஓட pair ஆயிருக்கா, connect ஆயிருக்கா, that we can come to know by reading this particular pin, state pin. Yes. Yes, is it clear? By reading that particular pin, state equal to 1 அப்படினா meaning என்னன்னு பார்த்தோம்னா no connection. Yes. Is these things are clear to everyone? Then enable pin, it is used for some other purpose. Later I will tell you, possibly in the next sessions I will tell you. Fine. So how we have to connect? Ground to ground, VCC to VCC, TXD to RxD of microcontroller, RxD to TXD of microcontroller. Now I am going to provide the connection. Wait a moment. Okay. Wait a moment. So I have to give the connections. After taken the wire, I will show you the camera again. Wait for some time. I am taking 4 wires now. My interest is, yes, my interest is to connect these 4 wires to the microcontroller. Wait a minute. VCC, ground, TXD, RXD. Now I'm going to connect it with the microcontroller. Already you people seen the microcontroller. When you people came to the college, you people seen the microcontroller. I will show you how to connect. Wait a minute. After given the connection, I will tell you. So RXD, I have to connect to TXD. Yes, TXD, I have to connect to RXD. Then we have to provide ground. Later, we have to provide 5 volts. That's it. 4 wires only I am connecting now. Fine. I will show you now. Yes, I have taken 4 wires from this lines RXD, TXD, ground and VCC, and I am connecting like this. Okay, you can see. Here you can see. Wait a minute. Here you can see. Yes, TXD pin, RXD pin I have connected. Then 5 volt and ground. Yes. So this board already you people had seen in the college. When you people came to college, you people seen this board. Fine. So only 4 connection I am establishing. That's all about the connection. Now what I am going to do is, wait a minute. Now what I am going to do is, I am going to connect one LED, or else we can use the onboard LED itself. Yes, it is connected at already P2.0 only. It is already connected, so no worries. So now what I am going to do is, I am going to open the app Bluetooth terminal. If you open this particular app, it will ask you permission to turn on the Bluetooth. Yes, I am setting yes. Okay, fine. Now, before this, I am going to Bluetooth settings in my mobile phone. Wait a minute, I have to power on the board first. After given the connection, I am just providing the power to my microcontroller. So from the microcontroller board, it will draw the power for the Bluetooth. Yes. So now I am going to connect it. Yes. Now you people can see. Now you people can see. This particular button is blinking very fast. Correct? That means there is no connection established till now. So this is about the hardware. Microcontroller, I have connected the Bluetooth. Yes. Now I am going to open the app. I mean Bluetooth settings I am going to open. Wait a minute. Yes. Here I am going to unpair this. Wait a minute. So that I can do from the beginning. I am doing unpair. Now I am stopping the Bluetooth, turning on. Now you can see only one device. I have named this device as ACE Blue. The later session I will tell you how to rename this particular Bluetooth device, or you can change the password. Everything I will tell you. As of now, it is asking a password. I had set it as 2679. By default, it is having the password as 1234. Enable to pair. Wait a minute. Two, three, four. Yes, by default it is 1234 only. I will change the password as 1234 itself. I will tell you later how to change the password, naming, configuration, everything. Right? Now our interest is when I send zero logic from the mobile phone, it is receiving through wireless to the Bluetooth device. The Bluetooth device is going to transmit the data to the reception pin of microcontroller. So this is the thing going to happen now. Fine. So I have written the program and I had compiled it already. So it is available ready. Wait a minute. Yes. Okay. So this is our program, right? Yes. So now I have to go to the Bluetooth app, Bluetooth terminal HC05. Now you can see only one Bluetooth device, my Blue. I am going to click on it. It got connected. Okay. Already some coding is burned into this particular Bluetooth module. Hi everyone, that code is working now. Fine. So what I have to do, I have to put my coding again into the microcontroller. Fine. So what I have to do initially is I am clicking on the button. I am going to rename this button as LED off. Saving it. The next button I am renaming it as LED on. LED on. Fine. So in this, I have checked the value as 1. Can you see command is equal to 1? This is the data I am going to send. It is in the form of ASCII. If you want, you can have hexadecimal value also. Fine. You have to disable these two particular boxes. Fine. Later point of time, I will explain you what are the purpose of this particular boxes. Fine. So I am clicking on save. So LED off, it is 0. Fine. For example, some other thing, button 3 near, fine, some other thing. So it is like this. So LED off, LED on. I am using only 2 pin. I can go for another pin also, LED toggle, so that we can modify the code. Wait a minute, LED toggle. So for this, I am going to assign value as 2. Yes, LED off, LED on, LED toggle. So 3 buttons I am having 0, 1, 2. Fine. Now I have to rewrite the code. I have to modify the code. Wait a minute. As I changed one more option, I have to include it. Wait a minute. Yes, wait a minute. If REC equal to 0, LED on. If REC equal to 1, LED off. If REC equal to 1, LED on. Else if REC equal to 2 means you have to toggle. Yes, for toggling the LED, what you have to do? LED equal to what we have to put? Yes, kindly type in chat. What we have to do? On means off, off means on. What we have to do? Yes. Students, kindly respond. Yes. Not symbol I have to use, LED, that's it. Fine. Now I am going to put an else statement. Else it won't do nothing. Won't do nothing. So simulator, debug this file. Yes. Okay, which software we have to use to burn the code? Do you people remember? Yes, which software we have to use to burn the code? It's still assembling the code. Wait a minute. Warning. Yes, what about the warning? Variable B may be used before initialization. Wait a minute. Okay, no issue. We are passing the value. Yes. So B is not initialized in this particular code. So what we have to do? B is equal to count. Yes, this is the formula we have written. Count is equal to 256 minus S clock. Yes. So that value we are computing here. That is one error I had did in the program. Wait a minute. It's taking more time to compile. Wait a minute. Overflow in implicit function. Wait a minute. Okay, or else I will directly put a count value as of now. So B is equal to, what about the value we found on that day? Do you people remember? FD, correct? 0x FD. Directly I can put. No need of this value. 0xFP. On the day we found out now 0xFP. For generating baud rate of 9600, I am doing this. So B variable we know it, no need it now. This lines of coding also not needed now. Yes, directly I am putting the value because we are running out of time. Yes, that's it. Compilation is successful. So now I am going to open an app to burn the code. So for that, I am going to open an app. Wait a minute. I think in desktop it is available. Rogue ISP. Yes. Okay. So now what I have to do? Load flash. I have to check where I have stored the code. Yes, time is 11:51. So this code is the recent one. Okay. Open. So I have to burn it. So meanwhile, I can show you the screen. So now also it is sending the same line. Hi everyone. Correct. So now I am going to burn the code. Okay. Now I am going to clear this window. Fine. So now what I am going to do is I am going to give the inputs. Wait a minute. The program got burned successfully. So initially what I am doing, LED on, I am clicking. Okay, you can see. Wait a minute. I will open my camera so that you can see. Yes, is the blue LED is on? Sorry, green LED is on. Connected at P 2.0. Now what I am going to do is I am going to send the command as off. Okay, now you can see. What about the condition of the LED now? It got turned off. Correct? So now what I am going to do is I am going to give it as toggle. There you can see it changes from 0 to 1. If I press again toggle, it will get turned off. Yes, is the program is working correct? Instead of this LED, if you connect any home appliance through some driver circuit or relay, it is going to work fine. So it is going to be a home automation project. In your embedded system, you can provide a wireless interface like this device by using this device, Bluetooth or Wi-Fi, any module you can go with. Fine. In the next class, I will tell you. Next session, probably I will tell you how to configure this Bluetooth. Fine. This Bluetooth are coming with a default baud rate of 9600. Fine. It can be changed to some other baud rate also. Fine. I hope you people understand it's working. Yes or no? Is it working or not? Now I am going to turn on the LED. Yes, you can see it now. Yes. That's it. See, whatever the thing we are giving at the terminal, so it is reflecting there. That's it. Okay, students, I want to tell you one thing. So now I will go with the acknowledgement program. So now there is no acknowledgement from the receiving side. Correct? So இங்க நான் கொடுக்கிற டேட்டாக்கு என்ன ரெஸ்பான்ஸ் LED ஆன் ஆச்சா என்னன்றது எனக்கு ரெஸ்பான்ஸ் வரல. Fine. That means what? I may not ensure whether it received the device properly or not. So for this purpose, what we are going to do is we are going to add few more lines. So at the end of this RI routine, whenever I receive a data, it is doing some action. After doing some action, I am manually enabling the transmit interrupt. Software enabled. Through software, I am enabling. What will happen? Now what will happen? this particular loop, okay, this particular loop, if Ra equal to 1, this particular loop will start run, if loop will run, fine, if statement will be executing. After coming out of this if statement, it won't go to the else statement, because if statement is satisfied, it won't go to the next thing. It will go out of the ISR routine. Fine. So now what I am going to do is I am manually generating the interrupt, transmit interrupt. So after coming out of this service routine, again it has the tendency to come into the interrupt service. At that point of time, it will enter into which loop, whether the first one or the second one. Kindly type in chat. Yes. If Ra equal to 1 kulla poguma illa else statement kulla poguma. Now the interrupt is due to transmission. Yes or no? Yes, it should enter into TI. So in the TI line, I am going to again compare. Last, I had read the value REC, correct? So here I am going to compare. If REC equal to 0, yes, if REC equal to 0, what we have to do? What we have to do? We have to transmit the message LED turned on, LED turned on, correct? So for this, what I am going to do is I am going to create some messages, _code const char mess 1. இல்லனா என்ன பண்ணிக்கலாம், mess 1 னே வெச்சுக்கலாம், message 1. Message 1 must be LED turned off. Okay, at the end I am going to put slash n. Okay, similarly I have to generate, similarly I have to do, yes, similarly I have to do two other messages. So LED turned on, LED toggle, invalid input. Yes, so message 1 is LED turned off, message 2 is LED turned on, message 3 is going to be LED toggle, yes. So this one, message 4 is going to be error message. Error message enna kudukalam, invalid input. Other than 0, 1, 2, if you get any input, invalid input. That's all. Okay, so these are the messages I have to send as an acknowledgement. Yes, for sending this, we need one reference. One reference we need. What we can do is share some value we have to assign. Yes, no. Yes, initially S is equal to 0. Kindly note down, initially S is equal to 0. Fine. So after getting into this particular thing, I need to have one more status bit, _bit status equal to 0. Initially it is going to be 0. Fine. _bit status equal to 0. Fine. If REC equal to 0, next what I have to do, if, okay, wait a minute. If status equal to 0 இருந்துச்சுனா, if status equal to 0 இருந்துச்சுனா உள்ள வந்து என்ன பண்ணணும், while I have to read the value na, just while la gavaninga mess 1 of, yes, initially what about the value I have put, S equal to 0, correct? S equal to 0. Yes, first time உள்ள வரப்ப mess of 1 not equal to null 0x00. Yes, if it is not equal to null, what it should do? S buff is equal to mess 1 of S. That's it. Okay. If status equal to 0, that means till the message not transmitted, it will keep on executing. Okay. Or else what you can do? You can avoid this status. You can avoid this status. Wait a minute. Or else you can avoid this status. While mess of 1 not equal to 0, it will execute this loop. We should not put while loop. Sorry. We should not put while loop because it will keep on executing this line. Okay. So what we have to do is, if status we have to use, if status equal to 0 means message not transmitted yet. So here also we have to use if statement. If mess of 1 of S not equal to 0, we have to write else what we have to do? Else status equal to 0, status equal to 1. Yes, similarly we have to make S equal to 0. Why I am doing this thing is, till null character occur, whenever interrupt comes, so it will come. If status equal to 0, it will come like this. Clear? அப்ப இங்க என்ன பண்ணிருக்கணும் அப்படின்னு பாத்தீங்கன்னா, status equal to 0. It's a global bit variable. Fine. After I received a byte, I am resetting the status flag bit initially. Fine. At the same time, S value I have to make it 0. That's it. So here, if the received byte, yes, if the received byte is equal to 0, the received byte is equal to 0 and status is 0. If the character is not null, okay, we have to write the value to the Bluetooth device, okay, and we will go off. Else what we have to do? If it is equal to null character means status bit we are making it as 1 and S equal to 0. Fine. Fine. Is it clear? If it is equal to null character, status bit I am making it as 1, okay, and S equal to 0. Yes, like this we have to write for the other buttons. Wait a minute. Control C. Only wait for 5 minutes, students. I will complete it off. Just 1 status. Mess 2 here. Message 2 should be displayed. Yes. Let's go with the next one. Here I have to put else if. Okay, else. See, I'm going to stop with only 2 buttons. I'm not going to consider the toggle thing. Here what we have to do? If status equal to 0, next 3, yes, invalid message, error message. 4, sorry. I have to change it as 4. Here it is 2. Here it should be 4. Mess of 4. Message 4 should be displayed. Yes, that's it, students. That's it. I didn't consider toggle condition. Now I am considering only this is up to for reception, correct? Yes, if RA equal to 1, we are doing all those things. So at the end, we are enabling the interrupt first time, status equal to 0, S equal to 0, and A equal to 0. If REC equal to 0, then we have to check status. If status equal to 0, then we have to take the data. If the data is not equal to null, we can write it. இந்த எல்லா கண்டிஷனும் satisfy ஆனாதான் இதுக்குள்ள வரணும். Yes, else status equal to 1 and s equal to 0. That's all. So now we will burn the code now. So this file, yes. I made one mistake. Wait a minute. Double underscore 4. Yes, I missed the semicolon. Sorry. I think we have mistake. Correct only. Yes, can you people see any mistake in the program? Yes, here I missed the semicolon. Okay, somewhere I missed another mistake. Wait a minute. If else if which I put else or time number 1 I have to close. If REC equal to 0, we are doing this. Here I put one extra bracket. One, two, three, four. Here else check it now. Yes, now it's okay. So now I'm going to burn the code. Wait a minute. Load flash. Yes, I have burned the code. Wait a minute. We will see the output now. Yes, now opening the app. Okay, please listen. I'm going to send LED off. Only first character it is displaying. Yes, I missed to point the next characters. Sorry. When we are writing some program in emergence, we may made more mistake. Yes, here I have to made s equal to s plus 1. After transmitting one data, I have to made s is equal to s plus 1. After writing the data, we have to point to the next one, s is equal to s plus 1. Or simply s plus plus we can put. S equal to s plus 1. Here also I am going to make it as s is equal to s plus 1. I have to burn the code again. Sorry for taking this much time. So with this, we will wind up session. Okay. Okay, now I am going to click on LED on. Yes. Have you got the message? LED turned on. Can we see it now? Can go with the camera. Yes, it is turned on. Am I right? Yes, now what I am going to do is LED turn off on a porom. Yes, LED turned off. What about the message? What about the hardware? It got turned off, right? If I am clicking on LED underscore toggle, it is showing invalid input. Why it is showing invalid input? I didn't write any function, but it works out. Hardware la change nadandiruchi. Software la na innum eludala. Correct? As time is running out, I had did only for the 2 buttons. So if I put any other button, wait a minute, I have to assign some value, then only I can put. For example, I am sending the value as 9. Yes, if I am sending the value as 9, invalid input. There is no change in the hardware also. Yes, I hope it is clear to everyone. So like this, you can do many apps. So regarding the MIT app inverter, from next session onwards, tomorrow session onwards, Gun sir will handle you. Fine. Meanwhile, I will show you, I will explain you how to configure this Bluetooth device. Fine. You can do some simple projects. Okay, you can purchase and you can do it. We don't have UART simulation in this particular software. That is the huge drawback we are having with this particular simulator. Fine. Okay. Students, ECEA class students, tomorrow you people be ready to present. Fine. As time was finished, the next session, okay, the last half an hour or 20 minutes, you people have to present. Okay. I think few of you students got permission from me. Fine. I have granted permission for today, but tomorrow you people have to present compulsory. Fine. If you have any issues, you kindly contact me. You people are having my number. Okay. Or else I will type my number in both meeting link, so you people can make use of it. Okay. If you are sending any message, you just mention your class and the name so that I can understand. Yes, I have shared my personal number in the chat. Kindly make use of it. Yes. See, the very worst thing is we are at the online class. That means I cannot able to explore many hardwares to you people. Fine. We have worked with many hardwares, but unfortunately we cannot able to reveal all those things through this online class. Fine. That is the drawback of this class. Anyhow, at least we had such provisions to demonstrate all our coding and the simulation, everything. Fine. So now I am going to disable the recording. If you people have any doubts, you stay here and ask doubts. Otherwise, you people can leave. Thank you to everyone.